Hello and welcome to Week 10, Part 5 of EGM310, Satellite Data. In this lesson, we'll learn about different Earth observation satellite missions. You may not realize it, but we are currently living in a golden age for satellite imagery. This diagram shows a number of different optical satellite programs since the early 1970s when Earth observation satellite missions started. For the first 10 or 15 years or so, there wasn't very much available. We really only had the different Landsat missions up until about 1986 with the launch of the first French Satellite pour l'observation de la Terre, or SPOT-1. Around 2000, we added a few more sensors, including Aster and Modus, along with Iconos, one of the first really high-resolution imaging satellites. And then, after about 2010 or so, the number of satellites acquiring data really exploded. But the thing that makes this a golden age is not just the number of satellites acquiring data. Some of these, especially the really high-resolution sensors, such as the different Worldview satellites, SPOT and Pléiade, are also extremely expensive images. To be able to look at large areas over longer periods of time, you need to have a lot of money. No, what makes this a truly golden age for satellite data is that beginning in 2008, the U.S. Geological Survey opened the Landsat archive up. From that time on, any and all Landsat images acquired by the USGS are available for free to anyone. Beginning in 2016, NASA did the same thing for the Aster archive. From the moment it launched, Sentinel II data have been freely available to anyone. We have 40 plus years of satellite images that are now freely available, which has truly transformed remote sensing studies. Before 2008, most studies would be able to use a few images, which places severe limits on the things that we can hope to see with remote sensing. Since 2008, we've had studies that have used thousands, or tens of thousands, or even hundreds of thousands of images, and it has completely transformed what we can observe using remote sensing. We'll begin with the Landsat program, which is the flagship Earth observation satellite program. It began in 1972 with the launch of Earth Resources Technology Satellite 1, or ERTS-1, which was later renamed Landsat-1. It is run jointly between the U.S. Geological Survey and NASA, and it has consisted of a number of different sensors. Landsat 1 through 5 carried the multispectral scanner, which had 4 bands in the visible and near-infrared wavelengths. Landsat 4 through 5 also had a band in the thermal wavelengths. The second sensor is the thematic mapper, which was carried by Landsat 4 and 5. After that came the Enhanced Thematic Mapper Plus, which was carried by Landsat 6 and 7, though Landsat 6 failed to reach orbit on launch in 1993. Finally, we have the Operational Land Imager and the Thermal Infrared Sensor, both carried by Landsat 8. As I mentioned before, the whole archive has been free since 2008, marking nearly 50 years of observations, with more coming in daily, and the launch of Landsat 9 planned for sometime next year. Landsat 4 through 5 has 16-day repeat coverage, meaning that every 16 days the satellite covers the same area on the Earth from the same viewing angle. The multispectral scanner instrument had approximately 60-meter spatial resolution for all of its bands with a 185-kilometer swath width. The thematic mapper, carried by Landsat 4 and 5, had 7 bands, 4 in the visible and near-infrared, 2 in the shortwave infrared, and 1 in the thermal infrared. The thermal band had a spatial resolution of 120 meters, while the other 6 bands had a spatial resolution of 30 meters. The Enhanced Thematic Mapper Plus was nearly identical to the Thematic Mapper, although it added a panchromatic band with 15 meters spatial resolution. Each of these sensors were optical mechanical scanners, or whisk broom sensors, and they all have a radiometric resolution of 8 bits. That is, each band has a total of 256 possible gray values. The Operational Land Imager and Thermal Infrared Sensor carried by Landsat 8 are push broom instruments, and they have a radiometric resolution of 12 bits, or 4,096 gray values. In addition to the 30-meter visible near-infrared and shortwave infrared and 15-meter panchromatic bands, the OLI also has a coastal and aerosol band and a cirrus band, which are used for studying atmospheric aerosols, coastal areas, and clouds, each with a 30-meter spatial resolution. The TIRS sensor also has two separate thermal bands with 100 meters spatial resolution. The Advanced Spaceborne Thermal Emission and Reflection Radiometer, or Aster, is a joint mission shared by NASA and the Japanese Space Agency. It was launched in December 1999 aboard NASA's Terra satellite, and it began acquiring images in March 2000. The sensor consists of three different systems. The visible and near-infrared system has three bands at 15 meters spatial resolution. The shortwave infrared system, with 6 bands at 30 meters, stopped working in 2008. And the thermal infrared system, which has 5 bands at 90 meters resolution. Aster also acquires stereo images in the near-infrared, which allows for calculating topography. And like Landsat, the Aster archive was made freely available from April 2016, providing a time series of over 20 years of global elevation as well as elevation change. This allows us to study things like glacier melt, but potentially also deforestation, large-scale erosion, and other subjects. Sentinel II is a part of the EU's Copernicus program, operated by the European Space Agency. It was first launched in 2015, and since 2017, it has been a tandem mission of 2 satellites. This provides approximately 5-day repeat coverage of the globe. The instrument on board Sentinel II is known as the Multispectral Instrument, or MSI, which provides a number of different resolutions. The 4 visible and near-infrared bands have a spatial resolution of 10 meters, while 6 shortwave infrared and red edge bands, have a spatial resolution of 20 meters. The coastal aerosol, water vapor, and 2 cirrus bands each have a resolution of 60 meters. Like Landsat and Aster, Sentinel II data are provided absolutely free. In this lesson, we've learned that there is an unprecedented amount of global, freely available data with more images coming in daily. This explosion of data has changed the ways that we use remote sensing to study Earth's environment and processes. The archive data stretch back to 1972, with pretty good global coverage starting from about 1985 onwards. After the year 2000, we have multiple sensors and missions available with near simultaneous coverage, which greatly increases the number of images available. For each of the missions that I've covered in detail here, I've linked to the official mission website where you can find out more information about the different sensors, satellites, data, and so on. If you're interested in learning more about a particular sensor or mission, I suggest that you start there. That's all for this lesson. I hope you found it interesting, and if you have any questions, please don't hesitate to email me or post in the discussion forum on Blackboard. Bye!